Hello, students. We're doing three-dimensional shapes. We could seriously spend a week on this stuff, like just today's lesson. There's so many cool, like, Geogebra things that you can play with. I put lots of links. There are two historic characters that we're talking about today. They are Plato, who was a philosopher and did math stuff. He's named for his Platonic solids. Another math person that we're talking about today is a Swiss mathematician named Euler. All these different nets make a cube. It's kind of fun. This one, oh, I like that one. This one. So I hope that you look at some of those videos and things that I've posted and enjoy and play around a little bit. So we have a ton of new shapes. Do you know what these shapes are called? This one is the one people knew in class first. That's a cube. It's also a hexahedron. Do you know any of the other names of these shapes? This one is a pyramid. Pyramid. This happens to be a square pyramid because the base is a square. Maybe it's a rectangle, but that's close enough. You know any of these other shapes? This is also a pyramid. It goes up to a point. It's a triangular pyramid. And this one is actually one of the special Platonic solids. This one happens to be called a tetrahedron. Anyone know what this one's called? Yep, rectangular prism. This cube is also a rectangular prism. It's more special because all of the faces are regular. That means all four sides are the same and all four angles are the same. So it's more special. How about this? This is a prism. What's the base? What are the two that are the same? They're pentagons. So this is a pentagonal prism. So with prisms, they have two congruent parallel bases. So there's two pentagons that are exactly the same. This one has a 1, 2, 3. Is that hexagonal or pentagonal? 1, 2, 3, 4, 5. It's also a pentagonal, but this one is a pyramid. Pentagonal pyramid. All right, how about these two? These tripped students up today. They're not triangles, right? And they're not rectangles. They have two triangles that are congruent and parallel. So this is going to be a triangular prism. If you want to get more specific, if you knew that these are equilateral, you could say it's an equilateral triangular prism. Do we know what kind of triangle this is? Yeah, we do. It's a right triangular prism because it has the right angle. Again, the triangles are parallel and congruent. So they're the bases. Even though it's sitting on this rectangle, these are still the bases. So those are all three-dimensional shapes. These are the famous ones. These are called the Platonic solids. And Plato was a philosopher, and he also dabbled in math and just thinking about thinking. And one thing that he thought about is that there's perfect shapes in our mind, like more perfect than we could draw or create in any way. They're called the forms. So if I say, everyone close your eyes and think of the perfect circle, we can think of a more perfect circle than we could ever make. Okay, so these are the 5 Platonic solids. This is called a tetrahedron. This might remind you, if you're a gamer, like Dungeons and Dragons dice. These are, you know, kind of dice shaped. What else can I tell you? There are 5 platonic solids in 3 dimensions, but if you go to the 4th dimension, there is a 6th platonic solid. I posted a video about that if you're interested. We know this is a cube. For a solid to be platonic or to be one of these 5 most special, all the angles at the vertices have to be the same. So all 3 of these are right angles. All the sides have to be congruent. So all of these are perfect squares. And so all 4 sides of the square are congruent and all 4 angles of the square are congruent. So it's regular quadrilateral. And then all 6 sides of this thing, all 6 faces, all 6 faces are congruent. These are equilateral triangles. 3 of the platonic solids are made of equilateral triangles. This one, tetrahedron. How many faces does this one have? How many equilateral triangles is it made up of? Yeah, it's 8. And what animal lives in the sea with 8 legs? An octopus. So it's an octahedron. This one is my favorite shape of all time. This is a dodecahedron. Dodecahedron. And deca means 10. Dodeca means 12. So this one has 12 faces. 12 faces. Tetra is 4. Cube has 6 faces. An octahedron has 8 faces. Anyone know what this one's called? It has 20 faces. Again, if you play dice games, you might see this one. This is an ID 20 because it has 20 faces. And it is an icosahedron. Yay, icosahedron. So those are cool. What we spent some time in class doing is counting, because we can name these shapes and we can count their parts. So if we're going to count the faces, what that really means is counting the polygons. Kind of, if we go back and look at that net, if I open this net, I can see how many, 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 polygons that create that 3-dimensional shape. Those are called faces. If I count the vertices, those are the corners, those are the points. I'm going to count the points at all the corners. And the edges are going to be the line segments. Okay, so let me show you. This is a rectangular prism. And it has 6 faces. And it has how many points? Well, 1, 2, 3, 4, 5, 6, 8 points. And it has a total of how many edges? For the edges are 1, 2, 3, 4 vertical, and then 5, 6, 7, 8 along the top, and 9, 10, 11, 12. It has 12 edges. The tetrahedron has 4 sides, 4 faces, I should say, excuse me, 4 faces. It has 1, 2, 3, 4 vertices, the points where the points at the intersection. Okay, it has only 4 of them. There they are, 1, 2, 3, 4. And how many edges does it have? It has 1, 2, 3, 4, 5, 6. And there's a relationship here. I'm going to write it by hand. That's a cube. Also has 6, 8, and 12. I wonder why. This is a square pyramid. and this has 1, 2, 3, 4, 5 faces. Interesting. It's our first odd number, isn't it? And we have 5 also vertices. And how many edges? We have 4 along the bottom, 5, 6, 7, 8. As I continue to do this, I want you to look at these numbers and see if there's a pattern that you see. This is going to be our triangular prism. It has 1, 2, 3, 4, 5. It has 1, 2, 3, 4, 5, 6. And it has 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. Okay, this is also a triangular prism, so this is also 5, 6, and 9. This is our octahedron. It has 8 faces. It has 4, 5, 6 vertices, and it has a lot of edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. All right, I'm going to leave that for now. And does anyone see any patterns? Is there anything you can do with these two numbers to tell you what this number is going to be? If I covered up this column and I said, just kidding, I'm not going to tell you how many edges. Could you figure it out? Could you figure out how many edges if I gave you the faces and the vertices? That's where the guy Euler came in, and he said, yeah, look, what's 4 plus 4? 4 plus 4 is 8. But what's 8 minus 2? 6. How about 5 plus 5? 5 plus 5 is 10. What's 10 minus 2? 8. Does it work? Let's try this one. 8 plus 6. That's 14, isn't it? What's 14 minus 2? 12. Kind of cool, right? So that's what Euler said. He's really famous. He was a Swiss mathematician, like I said. And he came up with this formula, which always holds for all polyhedron. And that is, if you know the number of faces and you know the number of vertices, and you subtract 2, that's going to give you the number of edges. So that's kind of a fun formula to know. It's an interesting relationship that happens with 3-dimensional figures. There's 2 more things I want to go over with you. One is that solids are generated by spinning polygons. So can you imagine what shape I'm going to get if I spin an isosceles triangle? Oh, I gave it away. It's a cone. Okay, so if you start to spin this, you'll see that you'll get a perfect cone shape. And in calculus, we spend a lot of time taking shapes and spinning them around a vertical or a horizontal axis, or a different axis. The last thing that we're going to talk about really quickly is cross sections. And I put a fun little video together for you on ninjas. It's a little ninja and it comes in and slices the shape into different pieces. And I highly recommend that you watch that as well. So you could do this cross section parallel to the base, and then you can see this shape. If I took this plane and held it up, you would see on the flat surface would be a pentagon. But just because the base is a pentagon doesn't necessarily mean you're always going to get a pentagon. This happens to be a cross section that's parallel to the base. We could call it a horizontal cross section. Horizontal to the base. And what you have is a sort of a similar, same size, but a different shape of the base. As it gets closer to the top, it gets smaller and smaller, right? Okay, I hope you find this stuff interesting. Please play around with all the fun stuff I I put in there for you. Be good, work hard, keep learning. Bye.